Hello students, you're welcome to Edu Math Hub. So we're going to be taking some questions on heat transfer for JAMB 2025 Physics. So we'll be doing some quick revision as we're answering the questions. So let's jump right into the video. Okay, let's go. So let's take the first question. So we're told that the heat from the sun, which is the earth, by the process of then A, insolation, precipitation, B, C, conduction, D, convection, and E, radiation. So you first of all need to know the modes of heat transfer. So for the modes of heat transfer, you have what is called, so for conduction, that is the mode of heat transfer in solids, okay, that does not involve the actual motion of the body, okay, the molecules of the body vibrates and the heat is transferred like that until it gets to the other end. This one occurs in fluids, that's convection. What's a fluid? A fluid is anything like a solid or a liquid. Okay, so this one involves the actual motion of the particles of the medium. Okay, the body itself will experience what is called movement or motion. Then radiation is the transfer of heat without any medium, okay, without any material medium. So that's how heat is transferred from the sun to the earth without any medium at all. So this one can occur through vacuum. Radiation can occur through a vacuum, but convection and conduction cannot occur through a vacuum. So if you go back to the question, you see the heat from the sun, which is the earth, by the process of, then you know that there is no material medium. Okay, there's no medium at all. So the correct answer to that question is radiation, which is option E. So option E is correct for this question. Okay. So the next one, we are told that two closed vessels contain equal volumes of boiling water. Okay, equal volumes of boiling water, and they are identical except that one is blackened. So one is painted black on the outside while the other is polished. Which of the following is correct? Before we go through the options, you need to know what's a black body first. Okay, what a black body is. So a black body and a polished body. So a black body is a good absorber or radiator of heat. Okay, if you are putting on a black shirt, you are likely to feel sweat easily. Okay, because the black shirt will absorb all the heat very fast. Unlike a polished body is like a body that is silvered, like something like white. A polished body is a poor absorber of heat or poor radiator of heat. If you are putting on a white shirt under a hot sun, you will not feel enough heat than someone that is putting on a black shirt under the hot sun. So a black color or a black body is a good absorber or radiator of heat. So that means if you put a hot object inside a black container, this object will get cooler faster because the heat will be coming out through the black surface of the body. So this object will get cooler. All the heat will escape. It will get cooler faster than when you place a hot object in a body that is polished, that is shiny. This object will radiate heat poorly, so the body will still be hot, while the one in the black body will lose all its heat because a black color is a good absorber or radiator of heat. So go back to the question. You see that they're telling you that what will happen. Okay, so the option A is the polished vessel will cool faster because a polished surface is a good radiator. That's wrong. A polished surface is a poor radiator. So A is wrong. The polished surface will cool faster because it will absorb less heat from the room. That's also wrong. The black vessel will cool faster because it is a better conductor of heat. Then option D, the polished surface will cool faster because it reflects heat better. And the last one, option E, the black vessel will cool faster because a black surface radiates heat faster than a polished one. So that's the correct answer. A black surface, the one in the black container, will cool faster because it will radiate all its heat faster. It will give out all its heat faster because a black surface is a good radiator of heat than a polished surface. So the answer is option E. Okay, so for number 3, which of the following statements is correct? Severed walls of a vacuum flask are used to prevent dash. So you need to understand what the vacuum flask is first before you can answer this question. So let's talk about the vacuum flask real quick. So this is the basic diagram of a vacuum flask. So a vacuum flask is just like a container that is silvered on the outside. Okay, it is polished on the outside. It has a reflecting coating on the outside. It is shiny on the outside. So you place a liquid inside. So it is used to conserve heat in the liquid or food. So if you place a hot fluid inside or a hot food inside, the food is going to be hot for a long time. The same thing, if you place a cold object, it's going to be cold for a long time. So it has a stopper. So this stopper is made of a material of low conductivity. So this stopper will prevent heat loss by conduction. Okay, and it has to be airtight. There must be no space there. Like there must be no air, as in space where air can come in, so that you will not lose heat by convection, as in through this liquid here. Okay, so that's for that. Then there's a vacuum in this part here. There's a vacuum, an airtight enclosure. So this vacuum prevents heat loss by two methods, by conduction and convection. That is because heat cannot pass through a vacuum by means of conduction or convection. Conduction and convection cannot occur in a vacuum. Then the external part here, it is shiny surface. It is a reflecting surface. So it doesn't prevent heat loss by radiation. So anytime you see anything like shiny surface, reflecting surface, just go to radiation straight up. Okay, and when you see vacuum, go to conduction and convection. Okay, then anything stopper, if it's airtight, it's going to prevent heat loss by convection. Okay, but if it's just ordinary stopper, it's going to prevent heat loss by conduction. So these are the basic things you need to know about your vacuum flask. So let's go back to the next question. Let's go back to the question. So this is the question here for number 3. Which of the following is correct? So silvered walls of a vacuum flask are used to prevent. Now you have seen silvered walls, so your eye should be on radiation. Just looking at the options and looking for radiation there, because the silvered walls prevent heat loss by radiation, just like what I just explained. So if you check the options, well, you see heat loss due to conduction. So it cannot be A, it cannot be vacuum loss. So it cannot be heat entry into inner flask due to convection. So it has to be D, heat loss due to radiation. So number 3 is D. So heat may be transferred by conduction, convection, and radiation. Okay, number 4 now. By which of this method does heat travel through a vacuum? So a vacuum does not have any material medium. Heat can only transfer or be transferred through a vacuum by only one method, and the method is radiation. So let's take the next question. So let's take number 6. So we are told that a hot metal ball is suspended in the open air. As it cools, it loses heat by, then they give us these options here. So a hot metal ball suspended in an open air. They have a hot ball like this, and it is suspended in open air. Okay, so the only way it can lose it is by not by conduction, but by method that involves no material medium. That's radiation. Okay, so you cannot lose it by conduction or convection because it's not in contact with any solid. It's just suspended in the air. So the only answer there that is logical is radiation only. That's the only way you can lose heat. So the answer is option C. Then for the next one, the mode of heat transfer which does not require material medium. That's number 7. The mode of heat transfer which does not require a material medium is, this one is very straightforward. So the answer is radiation. Then number 8, in which of the following are the substances arranged in descending order of thermal conductivity? So they give you 3 materials there. You have copper, glass, and steel. So steel is a very good conductor of electricity. Okay, better than copper. So if you look at most of your plates, cups, and most of those things, they are made of steel, because steel is a good conductor. So steel should be higher, then glass should be last, because you are going to descending order. It should fall. So steel should be first, followed by copper, then glass should be last. So we need SCG. So we need steel, copper, glass. So just make sure glass is last. So steel, copper, glass. So you can see the answer is option B. So number 8 is B. The vacuum in the thermos flask helps to reduce heat transfer by. So the vacuum in the thermos flask helps to reduce heat transfer by. So the vacuum in the thermos flask helps to reduce heat loss by two methods. Okay, that's conduction and convection. Okay, so let's go to the option. Any option that has radiation cannot be the answer. So let's look for convection and conduction. So that's option B. Which of the following phenomena explains the fact that a house whose roof is coated with white paint will be cooler in the hot season than one painted with black paint? Don't forget that black is a good absorber of heat. If something is black, the thing will get hot faster, or it will get cooler faster. So a house painted with black paint on the roof will get hotter faster, during the hot season. But if you look at the option, the only way the house will get hot faster is by radiation, but there's no option like that here. Okay, maybe they made a mistake. This should have been radiation, or this should have been radiation. So it's not by conduction or convection. So the answer is radiation, but radiation is not in any of the options. So let's just skip it. So number 11 rather, when it is applied to one end of a metal rod, okay, the molecules at the other end soon begin to vibrate with greater amplitude than before because it has been transferred by. So this one is very, very straightforward. This is when you have a candle like this, for example, you have a flame like this and you place a metal object on it like this. So you are holding the object at this particular point. Okay, so if the flame is hitting this particular point, the particles that are here will start vibrating. But as they are vibrating, they'll be hitting each other. You know that the particles in a solid are closely packed. They are near each other. So as one is vibrating to hit the other one, that one will vibrate and vibrate to hit the other one. That's how they will be hitting each other until the heat is transferred to where you are holding. Then you have to drop it because it's going to be very, very hot. So this method of heat transfer is called conduction. So the answer is conduction. So because it has been transferred by, then 11 will be C. So next one, which of the following statements are correct? Land and sea breeze are natural convection currents. Convection may occur in liquids or gases, but not in solids. The vacuum in thermoflask prevents its loss due to convection only. Before you can answer this question, you need to know a little detail about convection. So let's go talk about convection. So convection is the mode of heat loss in what is called fluids. Now what's a fluid? A fluid can be gas or liquid. So take note, a solid is not a fluid. Fluid is only gas or liquid. So the mode of heat loss in fluids is what is called convection. And there's something called natural convection and artificial convection or forced convection. So forced convection is what happens in your AC. You have it in AC where you have a fan, a particular fan. This fan will blow cold air through a pipe. So once that cold air gets to the living room or to the parlor, everyone will now become cool. So you have a fan that is blowing air. So that's forced convection. The fan is forcing the air into the room. But it's also natural convection, which is what you have in land and sea breeze, or you also have it when you're boiling water. When you're boiling water, for example. So when you boil water, you see that there's this your flame here, for example, and this is the water here. These are the water particles. So as I'm heating the water from the bottom part, the particles at this bottom part, once they get heated, okay, they become very hot and they'll become light. So once they become light, they will float upwards or they'll go upwards. Okay, while the ones at the top, which are colder, they are denser or they are heavier. So those ones will come down. Those ones will come down. Okay, they will come down. So some are going up, some are coming down. So as they're getting hotter, they go up. The heavier ones at the top will come down. Okay, at the end of the day, it looks a convection current. You see some going up like this and some coming down like this. So this is a natural convection current. This will occur until the whole liquid starts boiling. Okay, so that's what you need to know about that. Then let's go to the question. So which of the following are correct? So land and sea breeze are natural convection currents. So number 1 is true. Land and sea breeze is natural convection current. Boiling of water is also natural convection current. Convection may occur in liquid or gases, but not in solids. That's true. Convection only occurs in fluids. So number 2 is also true. Then for number 3, the vacuum in thermoflask prevents heat loss due to convection only. So that's wrong. The vacuum in thermal flask prevents heat loss by two methods, conduction or convection. So number 3 is wrong. Only 1 and 2 is correct. So the answer is 1 and 2 only. So option A is the answer. So number 13. A room is heated by means of charcoal fire. A room is heated by means of charcoal fire. An occupant of the room standing away from the fire is warmed mainly by, there's no material medium. So someone is heating the room and someone is standing in front of the fire. There's no wire or connection between the person and the flame. So the only method there is heat transfer without a material medium, which is what is called radiation. So that's the answer. So let's take the next set of questions. So for the next question, we are told that a room is heated by means, okay, we have done number 13 already. So number 14 now. So the space between the double glass walls of a thermal flask is evacuated. Okay, and two surfaces facing the evacuated space are silvered. The residual source of heat only takes place by, so the residual source of heat, you are wondering how will heat be lost since it has been silvered. So the silvered surface prevents heat loss by radiation, but they're asking how else will heat be lost. If they ask this kind of question, you have to choose the stopper. Okay, conduction through the stopper and the glass, because the vacuum will prevent heat loss by conduction and convection, and the silvered surface will prevent heat loss by radiation. So the only way heat can be lost is through the stopper and the glass, which is option C. So take note of that. Then two similar kettles containing equal masses of boiling water and are placed on a table. If the surface of one is highly polished and the surface of the other is covered with soot. Soot is like carbon, black. It's black in color. Which of the following is correct? So this is just like the similar one we did that time. Just know that if something is black, it will radiate heat, it will give out its heat faster, or it will absorb heat faster, any of the two. Okay, so in this question we are told that there is boiling water inside this container. So just look for the option that we have. The one covered with soot, it should get colder because it is painted with black, so it will lose all its heat fast. So let's go through the option. The two kettles will cool down at the same rate, so it cannot be A. That's wrong. The polished kettle cools down more quickly. That's also wrong. The kettle covered with soot cools down more quickly because it's a good rate of heat. Yes, so that's option C. The kettle covered with soot cools down more quickly by the process of heat convection. That's wrong. The only way is by process of radiation. So the kettle covered with soot cools down faster because it's a good rate of heat. So the answer is option C. So take note of that. Option C is the correct answer. So option C. Now a well-lagged bar of length 100 cm has its ends maintained at 100 degrees C and 40 degrees C respectively. We have to find what is the temperature at a point 60 cm from the hotter end. So this is under calculation. So we are told that the bar is 100 cm, Abi. Then one end is 100 degrees C. These two parts will be paired together. These are the upper end. They call it the upper fixed point. So we pair them together. While this 40 will be paired with the lower end of this bar, which is 0 cm. Okay, then 60 cm will be in the middle. Look how to solve it here. It's very simple. So draw a line like this first. Draw another line like this. This one will be for the bar. So the bar is 100 cm. So 100 will be here. Then 0 will be here. 0 cm. So this one here is for the temperature. So 100 degrees C will be at the upper point. Okay, at the upper freeze point. But we're told in the question that the other end is 40 degrees C. So 40 degrees C will correspond to the point that is 0 cm. So 0 cm, 40 degrees C, that's lower fixed point. Then 100 cm, 100 degrees C, that's upper fixed point. So we are told to find 60 cm here. Where will 60 cm point to on this bar? 0 is pointing to 40. 100 cm is pointing to 100 degrees C. What will 60 cm point to here? Which temperature will it point to? So let's just say Y. So you just use normal subtraction. You just do 100 minus Y. Okay, 100 minus Y divided by Y minus 40. Okay, then equals to 100 minus 60 divided by 60 minus 0. then you get your answer. So let's take the first part. 100 minus y divided by y minus 40. 100 minus y divided by y minus 40 is equals to, come here and do the same thing. See where I moved. 100 minus 60 divided by 60 minus 0. 100 minus 60 divided by 60 minus 0. Then if you break it down further, you're going to get 100 minus y divided by y minus 40. 100 minus 60 can give you 40. 60 minus 0, you have 60. So you cross multiply, you have 60 into 100 minus y. Then you expand 6,000. So collect the like terms, you add these two together. So 6,000 plus 16 is equals to 40y. This one will give you 100y. If you add these two, we get 76. So I'm dividing both sides by 100. So y will be 76 degrees. Then that's to tell you that this point here we point to 76 degrees Celsius. So go to your option and look for that there. So you can see the answer is option D, 76 degrees Celsius. Okay, so let's take the next one. The main reason for making the cover of a vacuum flask airtight is to prevent heat loss by, so I've said this one before, so to prevent heat loss by convection. Okay, that's why you make the cover to be airtight. Okay, prevent heat loss by convection. So that's D. So for the next question, the radiator of a motor car is cooled by dash. So a radiator of a motor car is cooled by convection. So that's straight up answer. Not by radiation. Be careful of that. Don't say because it is radiator, it will be irradiation. No, it is actually convection, because what you have in the radiator is like you have a fan. You have a fan, a big fan that is blowing air over water. There's a water in this container. Then this fan is blowing cool air like this. So the air is getting cooler from inside. This fan is blowing it through the engine of the car to make the car cooler. So this is forced convection. So that's the answer. For this next question, we are told that if 1.2 times 10 to the power 6 joules of heat energy is given off in 1 second from a vessel maintained at a temperature gradient of 30 Kelvin per meter. This is not kilometer. Take notes. The surface area of the vessel is, so this is Newton's law of cooling. So you need to use the formula. I'll give you the formula now. It's very, very simple. Power is equals to, then you need Ka dt over m. This is the formula here. So power, okay, which is the rate of heat loss, is equals to K. This K is the cooling constant or thermal conductivity to be given to you in the question. A is the area, change in temperature divided by m. M is the thickness. Everything like this here is called thermal gradient. That's heat or temperature divided by meter divided by distance. Okay, thermal gradient, that's everything here. So you can also write it like this. The energy or the power is equals to Ka, then thermal gradient. Let me just use THD. That's thermal gradient. So just check the question and put the values there. So you can see your K here. Your K is already here. K is 400. Thermal conductivity, that's the constant, is 400. Your energy is 1.2 times 10 to the power 6 joules. The time is 1 second. You will get the temperature gradient of 30 Kelvin per meter. So temperature gradient is 30. Energy 1.2. This is the time. This is K. So just substitute into the formula and get your answer. So if you put that here, you have 1.2 times 10 to the power 6. Your K is 400. You're told to find A, and your thermal gradient is 30. So you're looking for A, straightforward, which is 1.2 times 10 to the power 6. Okay, 400 times 30 will give you 1, 2, 3, then A. So let me just use a standard form method. So 1.2 times 10 to the power 6. Let me put this on a standard form. That's the same thing as 1.2 times 10 to the power. You know, there are 4 numbers here. Okay, you can see. So that will be 4. Then A will be here. So divide both sides. You can see that 1.2 is common. This one will cancel out. So you have 10 to the power 6 equals to 10 to the power 4A. So first method, this 10 to the power 4, when it comes here, it will remain 10 to the power 2. So that means 10 to the power 2 is equals to A. That means A is 100. 10 to the power 2 is 100. So A is 10 to the power 2 meters squared, or 100 meters squared. Anyone you want to use. So you can check that in the option. So you can see it from here. 1 times 10 to the power 2. Okay, 1 times 10 to the power 2, which is 100. Then next one, teapots are often silver coated to prevent heat loss by, anytime you see silver coated, anything silver coated, polished, whatever, just choose radiation straight up. So teapots are often silver coated to prevent heat loss by radiation only. Nothing concerns silver coated with convection and all this other stuff here. So just choose radiation. Answer is B. The thermoflask is designed to, now what's the function of thermoflask? So it's to prevent heat loss or gain. Don't forget, it's not only to prevent heat loss, it's to prevent heat loss or gain. And there are 3 modes there: conduction, convection, and radiation. So the thermoflask is to prevent heat gain by, not only heat gain, you need one that has heat loss and heat gain. So it's to prevent heat loss or gain. This one, to prevent heat loss or gain by conduction, convection, and radiation. So the answer is C. The blade of a hoe feels colder to touch in the morning than the wooden handle because the handle contains stored energy in the form of heat. The blade is placed at a lower temperature than the handle. The handle is a better conductor of heat than the blade. Yes, the blade is a better conductor of heat than the handle. Yes, it's D. The blade is a better conductor, not the handle is a better. You can see this thing is kind of tricky. If you're not careful, you're going to choose C. You have to be very careful. The handle is made of wood. Wood cannot be a better conductor of heat than blade, which is made of metal. So they're trying to confuse you. You have to be sharp. So blade is a better conductor of heat than the handle. So the answer is D. In the thermoflask, the main cause of heat loss is, now the main cause of heat loss in the thermoflask, okay, everything that the silvered was to prevent heat loss by radiation. The vacuum will prevent heat loss by conduction and convection. The only way it can be lost is through the cork, which is at the top. That's the cover. So if you see a question like this, just choose the cork, the cap. Okay, conduction through the cap or the cork. So the answer is option A. Conduction through the cork. The man standing 2 meters from a charcoal fire is warmed mainly by, so there's no connection between the man, everything is by, as in no material medium at all. Everything is through vacuum. The only way heat can be transferred through vacuum is by radiation. So the heat will get to the man by the method of radiation. Heat is radiated by all objects in the form of, so heat is radiated by all objects in the form of, it's not solar energy, it's by infrared rays. The infrared rays is an electromagnetic wave. Okay, it's one of the electromagnetic spectrum. So heat is radiated by all objects in the form of infrared rays. Okay, not X-ray, not solar energy. So take notes. Which of the following has no effect on radiation? Which of the following has no effect on radiation? Radiation can be affected by some factors, which is 1, temperature, the surface area of that particular object, and the nature of the surface. Because if it's black, it's going to be a good radiator. If it's polished or silver, it's going to be a poor radiator. If the area of that object is wide, it's going to radiate it a lot. If the temperature is high, it's going to radiate it a lot. So nothing concerns density with the radiation. Nothing concerns density, whether it is heavy or light. Nothing concerns density. The answer is option A. A perfect emitter or absorber of radiant energy is a perfect emitter, means a perfect radiator. So the color should be black. If you put on a black clothes in hot sun, you will get hot faster. You feel the heat faster. So a perfect emitter or absorber of radiant energy is a black body. Okay, a black body is the answer. The ground is always cold at night because the sun no longer shines at night. That's wrong. Atmosphere reflects the sun's energy at night. Atmosphere absorbs the sun's energy. The earth radiates heat to the atmosphere at night. That's the correct option. The earth will give its heat to the atmosphere. So once the earth gives its heat to the atmosphere will become hot, but the ground will become cold. The earth has given out its heat, so the ground will become cold. So the answer is option D. So for the next one, the mechanism of heat transfer from one point to another through the vibration of the molecules of the medium is very straightforward. The answer is conduction. Okay, in conduction, the molecules of the medium will vibrate. As they vibrate, they will hit each other, and that's how the heat will be transferred from left to right. Okay, that's conduction. So for number 31, heat transfer by convection in the liquid is due to D. Okay, increased vibration of the molecules of the liquid about their main position. That's wrong. That's actually conduction. Then variation of density of the liquid, expansion of the liquid as it's heated, and latent heat of evaporation. Nothing concerns that. So the answer is variation of density of the liquid. Let me explain it like this to you. You have a container like this. There's water here, and you are heating it from the bottom part. All these particles of liquid that are very hot, they will move up. Their density will become light. Once they become light, that means they are actually hot. They will move up. They will not be at this particular point here. While the ones that are actually heavier or cold at the top will now come down. Once they come down, they too will become hot and they will go up again. So it's about density here. The lighter the particle, they float upwards. The heavier they are, they will come downwards. Okay, so it's about the density of the liquid particles. So the answer is variation of density of the liquid. Then number 32, ice wrapped in a gauze placed at the bottom of a tube filled with water remains unmelted when heat is applied to the top of the tube. Okay, so you're saying like you have a container like this, a tube like this, and there is ice here, there's water here, and you are heating this particular top. You are heating it maybe with a candle. This ice will remain unmelted. It will remain solid. Why? So the question is trying to tell you to check if water is a good conductor. So ice cannot sink in water. That's wrong. This one is wrong. Water is a bad conductor of heat. This might be right. Water is a good medium to show convection. No. There's nothing like convection here. Ice is a solid that conducts heat. No. So the only answer is ice. The only answer is water is a bad conductor of heat, because the heat from this water is not flowing really fast downwards to melt this ice. So water is a bad conductor of heat. Then a room is heated by means of a charcoal fire. An occupant of the room standing away from the fire is warmed mainly by, this one is straightforward, the answer is radiation. Okay, so we've come to the end of the video. I hope you understand one or two things about heat transfer now. Okay, the next video will be on latent heat and specific capacity calculation, so watch out for the video. Thank you for watching. I really appreciate you. Please subscribe if you have not subscribed. Click the subscribe button right now, and then share this video with your friends. Thank you for watching. I'm going to post some more videos for you guys. Remain blessed. I love you guys. Take care. Bye.